Hello all, welcome to the latest edition of Times Techies. Today we're going to figure out how to design an electric motorbike, and we have with us two specialists in the field. We have Ranjita Ravi, who's the co-founder at Orxa Energies, and we have Prajwal Sabnis, who's also the co-founder at Orxa. So welcome to you both. Thanks a lot for joining the webinar. Why don't we just jump in? Tell us a little bit about Orxa, and we can start from there. I'm sure the audience would like to know.
Sure. So, Orxa Energies, it's pronounced Orxa. The Greek X
Sorry.
it's a conversation starter actually. X is a Greek guy, and it calls out to I suppose decades and decades of experience of Prajwal and our CTO in all that we do around simulations and everything. So Orxa Energies is a performance electric vehicle startup. We work on, and I use the word vehicles quite intentionally. We do electric motorcycles, which will be, I guess, what we're discussing today. But we also do work on aerospace and defense, and we can touch upon how that impacts our work on the electric briefly, we started the company in 2015. We have gone through multiple iterations of the motorcycle itself. Different materials, different chemistries, different.
This is the Mantis? Is that what it's called?
So the Mantis was launched a couple of days ago. It's now available for booking. So if you guys are interested, and any of the audience is interested in booking a Mantis, the booking links are open. You can book yourself a Mantis. Right? We have been doing test rides of a Mantis as well, and the Mantis has gone through a fair bit of a journey. So it went in, we unveiled the bike first in 2019 in India Bike Week, and then it was more than 200 kgs. Then it came down to about 190 kgs when we did the electric marathon, which was the world's, at that time, the world's longest ride on an electric motorcycle, 13,500 kilometers in 54 days around India. So that was the Bharatmala that we did. And that time it was still 190 plus kgs to the vehicle that launched a couple of days ago, which was a smidge more than 190 kgs. So it's been quite a journey in bringing that in. And I think we can talk about many things in terms of how we do structures, how we look at materials like aluminium. We are the only ones in this segment that has an all aluminum frame and subframe. Right? That's quite important. And also how we look at batteries as a structural element. So all of these things have gone into Orxa Energies and the journey of making the Mantis, how the Mantis.
Okay, maybe you can tell us what the process is like. How did you both of you start? When you decided you're gonna create electric motorbike, what was it like then?
Well, you want the official answer or the short answer?
Yeah, give us the long one.
Okay, so just look at the segment how it is, right? We are looking at what's called as a mid segment of motorcycles. You can say 200 to 500 cc kind of motorcycles. And they've been growing year on year for the last 7-8 years in India. Despite everything, despite the pandemic, despite BS6, despite ABS becoming mandatory in the segment, and all of these things, the aspiration of India cannot be ignored. And that shows up clearly in the numbers, right? And this shows up even in the way the big boys are making certain moves, right? For us, this is a dream segment, right? This is where we see a lot of growth happening and a lot of potential. And making electric motorcycles in this segment is a very difficult job because you need a large battery pack. Large battery pack means heavy weight. Large battery packs and large motors also means large currents to be managed safely. So safety, reliability, as well as ride quality, ride performance, these are things that become very important to manage. And these become bigger problems once you start reaching this segment. And of course, this segment doesn't mean you can blow the price out of the proportion, right? You can't make a bike for 5 lakhs, 6 lakhs, 7 lakhs for this segment. This is still an aspirational market, not a premium market. Okay? So these are things that go into the engineering considerations and the trade-offs we have to make to design this and design and build motorcycles for this segment. And electric motorcycles for us is because, I mean, I'm the sustainability person, Prajwal is the performance person. So
Okay.
that
We'll
together,
touch on both.
yeah. And we're all bikers. It's a hiring criteria at Orxa Energies. You all need,
Okay.
yeah, it is. It's a very strong hiring criteria at Orxa Energies. So put all of that together, and that's an electric motorcycle.
Hmm. Prajwal, you want to jump in? Maybe we can talk about the performance part of it. Did you decide right in the beginning how powerful it's going to be?
Look, I mean, yes. So I'm one of the prime decision makers in terms of what goes, what doesn't go on the bike, especially as far as the tech is concerned. But at the end of it, it has to be a product as a whole. It cannot be only one part of it. It's not only one aspect of it. Uh, there's, as Ranjita mentioned, there's a price consideration, there's some market anticipation that's there, but there's also from an engineering standpoint, what is feasible, what is not feasible. So if just from a consideration perspective, if someone says they're going to give you a carbon fiber frame in a sub 1 lakh kind of a category, that's not going to be feasible, right? It could also be from the point of view of which vendors are available to do what kind of operations to you to have what kind of product that can be pumped out. So there's a lot of other considerations that go into the matter. There's a lot of decision making that has happened, at least from our side, on whether we are going to build or make our own tech or buy it off the shelf. You find that when you do look at the Mantis, you do find that almost all the core tech in that has been developed ground up in house. It's always a challenging decision to make from an engineering perspective because many of these systems, a lot of people do as a cookie cutter approach. Many people build a separate business out of these things, and a lot of it we have actually consciously chosen to develop and evolve in-house purely from the point of view of the amount of control that we desired over those aspects of it. So at any given point of time, there's always a trade-off that needs to be made, taking into consideration not just the market aspect or the cost aspect of it, but also the entire product as a whole. And these are decisions that have a very clear, let's say, impact, not just on what you do today as a decision, but how that's going to impact you maybe 2, 3 years later. I think a lot of people, it is common knowledge in the management world that says, hindsight is always 2020. But when you start working on a product like, let's say, an electric motorcycle or a performance motorcycle, that is when when you start putting out vehicles on the road, when you start riding them yourself, that's when you start beginning to see the true impact of what that entails and which decisions lead to what and your flexibility there. So it's an interesting journey for sure.
Are there enough women bikers, Ranjita?
Yes. There are enough.
Increasing?
There are not enough. They're growing, I would say. And I think a lot of the aspects of electric motorcycles make them a lot more accessible. Because electric motorcycles usually do not have gears. You don't need to have gears because of the nature of electric motors and their
Right.
across different speeds. They're already quite efficient now. So you don't need to have gears. And I think psychologically makes them a lot more accessible. So we hope this will impact the riding scene a little bit because motorcycling for high energies is like in our DNA, it's in our essence. It's very important for us. We hope that bringing more electric motorcycles, not just the Mantis, but the vehicles after that as well, will help increase the number of all ages, genders of motorcycles.
Okay, let's take this part by part and how you built this. You mentioned weight. Weight is a huge deal, right? You brought it down from 190 to what 180 or something right now. What's that process? What's that process like?
Very painful.
Just Prajwal jumps into the details just as a context. In this segment, This would be the lightest electric motorcycle. All the other vehicles, electric motorcycles in India and abroad with similar powers, are definitely more than 200 kgs. Yeah. So
And the heavier it becomes more inefficient. Is that the problem?
difficult also maneuverability, right? It impacts your rideability as well.
It impacts your
Cost.
impacts your handling. Weight actually impacts so many things. And
Cost as well as you.
cost, not so much. I mean, you can always achieve a better cost or better. I mean, it's always a trade-off. So there are things that you can do to keep the cost down.
Okay.
I mean, easiest would be to probably take really thick, big blocks of tubes or something like that, and build together a frame very easily, and then you're going to end up with a very cheap, badly put together motorcycle, which is extremely heavy. So, but it's rideable. It's perfectly rideable. In fact, our first prototype was actually not too far from that. It was perfectly rideable, very nice, stiff frame, allowed for good handling, was very cheap, but extremely, lots of other considerations and trade-offs on that.
So after that first prototype, what happened after
So
that?
we iterated on many things as engineering ideas as well. So we started with different materials. So we went from steel to composites, aluminum. So then we decided on an all aluminum frame. Then in terms of how the batteries themselves were placed, because we had decided that 9 kilowatt hours was something that's important to us, this 200 kilometers kind of a range. And how do we make this 9 kilowatt hours and held, right? And then finally, so the journey from 200 to 190 was easier, but the journey from 190 to 180 was extremely difficult. In that we pretty much re-engineered the entire frame and made the battery a structural part of it. And of course, that has some benefits for the vehicle as well.
Okay. Well, what were those benefits? Prajwal, you wanna?
So primarily in terms of stiffness, right? So your frame is a lot more stiffer, which means when you clean the motorcycle, the handling is much better. We have managed to actually reduce the battery weight significantly by almost 10%. Effectively, the battery capacity on our wheels has actually gone up by about 15%, all the while meeting the more stringent requirements that came last year. I think so. As the journey has evolved, the norms have been getting stringent, more and more stringent because of the requirements of the field. At least, thankfully, in our case, a lot of our work from the other industries contribute to our developments. So whatever we learn on, say, deploying our battery packs in the aerospace field, agri drones and things like that, we actually translate to what we do here in automotive.
Okay. What about the motor? The engine?
Sorry?
The engine, the motor. How do you develop that?
Standard BLDC magnet motor.
Oh, that's easy. That's not a difficult.
I mean, in our case, it's well, it is customized. It is customized to our requirements. With a lot of localization, but the primary driver for us is, of course, the motor controllers are such a key part too. But getting them to work together with the other things is equally important. I find that the conversation in the Indian ecosystem is typically focused either around the motor controller and their efficiencies, or the battery and battery efficiencies
in isolation.
In isolation, but that's not entirely the complete picture, is what I feel, right?
Okay, and what about the battery? You just have to import that, I'm assuming. The battery?
The cells, of course, we import because lithium-ion cells in India, the manufacturing hasn't caught up to global standards yet. So the cells at least we import, but everything around the battery engineering, the BMS, the cloud system that allows us to manage every single battery module that we manufacture and put out there. And the thermal management that's involved in that, the lightweighting, the safety systems, all of that is designed and assembled in-house. We manufacture our own batteries.
I'm assuming there's a lot of R&D development you have to do, a lot of testing.
Yeah, definitely. I mean, we are, I think, on we are probably on the fourth generation of our batteries that we have built out.
10th generation of the BMS itself.
Yeah, the BMS is significant iterations, different sizes. We've done BMSs. So the battery pack right now is tested for operation between -40 to +60 degrees centigrade in terms of cold operations. So there's a significant amount of work that's done around the batteries themselves.
Okay, what about you have to do a lot of testing for the entire bike?
Yeah, definitely.
A lot of iteration.
Yeah. So I think a lot of the testing, one is of course what you need to do in terms of the testing standards themselves. So you have the homologation standards, and of course you need to pass that. But also when you talk about vehicles in the mid segment, right now you're talking about mid segment, and certain performance requirements are required. There are certain expectations in terms of how the vehicle ride dynamics is, how the vehicle feel is, and all of that. So definitely a lot of work, a lot of iteration, a lot of testing needs to be put in. The team also has to be quite agile in terms of how many times you can prototype, how quickly you can prototype.
Yeah.
Like during the pandemic and just after the pandemic, there was a semiconductor shortage, right? So we had to redo or work around a lot of the things at that time period. So the agility of the team also comes in then.
Okay. What about software? Is that a huge thing? Do you have to develop it yourself, or is it just open source? You can just take it.
You can work it both ways. In our case, for the most part, we've written it in-house because we do have so as a philosophy, we do have a very strong inclination towards doing things in-house, especially everything that's tech related. We have an enormous amount of emphasis on trying to use open source software. For example, all the design related work, all the design renders that we do that uses Blender significantly. We have been trying to incorporate things like OpenFOAM into our simulations. We build out a lot of in-house developed tools for all our numerical modeling, computational modeling. That's pretty much our background. So for me and my CTO, both we come from a very hardcore simulations background. So there is a lot of emphasis in terms of the softwares that we develop and how we deploy. So that kind of leads to a lot of things being done in-house, including the dash, including the UI system, all the firmware that gets coded onto the electronic boards, all the safety critical systems, all the warning systems, whatever gets communicated to servers, how you analyze the data on the servers, how you present the data. There's an enormous amount of work. And I think for us, the biggest learning has been that it's a lot better to find a very small, tight-knit team of very capable, very flexible engineers than to just build out a huge team. I mean, it's very common to see, I'd say it's very common to see hundreds of people building a company on one particular aspect or one particular area. That's one way to go about it. It's a wonderful way to scale. But in our case, because we are so focused on the tech and the marrying together of multiple technologies to make a larger product, we have a very strong philosophy and orientation to have a very small, tight-knit team, which performs very diverse functions. And we have a very huge inclination towards doing things in-house.
Leads to a lot of IP as well, and allows us to be flexible across industries. So it's an electric motorcycle, but we can do much more.
Yeah, and we have done much more.
Right. And Ranjita, what's your background? Engineering background?
What do you do with electric vehicles? I'm a biotech engineer.
Okay.
For the last decade or so of my career in pharma and biotech. And nothing to do specifically with pharma and biotech. I was in sales, I was in marketing, I was in internal audit. I used to work in a large pharma company out of France, which led me to travel more than 30 countries in the world with my work and otherwise. So that's my background before starting Orxa Energies.
And then how did you end up here?
So I think from a very long time. So Prajwal is a PhD, I'm the MBA. So I did my MBA in Paris. Prajwal did his MBA in Paris as well in another he did his PhD. Sorry, I'm the MBA. He's the PhD. He did his PhD at École des Mines and his master's in University of Stuttgart. And even before that, I think the objective was to always start something eventually. So once we had gained all of that experience and travel and seen what there are in different countries, it was important for us to come back to India and start something here, and hence Orxa Energies, and doing something in sustainability, doing something at very cutting edge of technology is a good combination. Is a good combination for us in terms of what we can do and what we can take to the world, not just keep it in India, but make it in India and take it to the world.
Prajwal, during engineering college days and stuff, what subjects have really helped you?
I think I was quite fond of machine design from my own personal interest, and I did pursue a lot on simulations. So fracture mechanics simulations during engineering, during masters, and during PhD. But at each stage, a little more advanced and a little more in depth in numerical mechanics. So just to give you a brief understanding of what I did during my masters and my PhD, most mechanical engineers today would be aware of softwares, such as ANSYS or SolidWorks or whatever it is, right? Or CAE. All these tools use materials. So someone has to model the material response mathematically for the computer to be able to simulate that. And a lot of my study has been around how to develop those materials and how do you represent real world behavior of materials or structures on a mathematical form so that you can use it in simulations. So I kind of essentially worked on the maths behind all these FEA software. And from that perspective, that's always been my background. And I did work with my CTO in Safran, the aerospace company. I worked there for about 2 years. We worked on a lot of different systems, landing gears, structures, fan blades, engines, things like that. And we worked a little bit on both, matching experiments and simulations. How do you do the numerical analysis? What goes, what doesn't go? So things like that. So it's a very detailed, applied approach. It's really learning and applying everything that you have done during engineering. So that's always been helpful. It did help that it's not so much about the exams or whatever. It's really about how curious you are about the subject and how much more you're willing to do. I mean, we find that the most let's say helpful hires or good engineers in our companies they come in two forms. Either someone who really likes to take up extra subjects, new subjects, and is curious about every single thing. It doesn't matter what the area of interest is, right? It could be in different area of engineering compared to what you're studying, or it could be in how the share markets work or stock market works or whatever. But they really need to be able to go into depth in every single aspect. The second types are, of course, a lot more practical and engineering oriented. These are typically people who join their BAHA, SAE, all these teams in colleges.
A lot of the good hires come from there.
And a lot of our good hires are typically people who have been captains at those teams. And so they know a little bit about what decisions to make, how to make those decisions, how to handle teams. Could be small, could be a 5-member team or a 10-member team or a 40-member team. That's not what we are looking for, right? So it's really about people who are curious and passionate about the craft that they're trying to do.
And the ability to correlate, especially the kids that come from these teams, they're able to understand what theory they're studying in their classes with respect to what they're doing on their formula vehicles or their Baha SAE, could be anything. But there is that ability to correlate and understand these concepts with the practical and apply them in a very constrained situation, because it's budget constrained, it's time constrained, it's all of that. That brings out a good engineer, really.
So we have some audience questions. We'll take some of those. Suresh Malia asks, while scooter vehicles are largely meant for shorter distances, bikers expect to ride long distances with motorbikes. How are you addressing this in your
I'll
product?
answer very quickly. 3 to 4 ways in which we're doing this. One, we believe that charging should be made easy for everyone. And motorcycles are meant for long rides. Yes, we completely agree with him. So we have a standard charger. We have a blitz charger, which will, so standard charger is from your 5 amp plug point. Blitz charger is from your 16 amp plug point. It will do your 0 to 80% in 2.5 hours. The Mantis is fast charging ready. So the new fast charging standard that has come and will be applied. The Mantis is ready for that. We are doing partnerships with charging players such that they will set up, say, about 100 fast charging stations along the highways in the next 1 year. Okay. So wherever we're rolling out the Mantises, you will have those fast charging charging stations, right? The last one is, of course, if you want to go somewhere where the fast charging network is not there, we are working on accessories where you can transport your blitz charger safely and securely, such that you can go anywhere and charge. So you want to go Bangalore to Coorg, Bangalore to Mysore, you'll get on one charge on the Mantis, no problem. But you want to go to Bangalore to Coorg, we are ready for that. Bangalore, Chennai, no problem. Bangalore, Pondicherry, no problem. So.
Yeah, Shreya Kajrolkar is asking, from a software standpoint, what additional checks and balances have you added for your bike, as this is a segment where speed is important?
So I think from a software perspective, the checks and balances are at multiple levels. So it depends on what layer of software you're working on. In terms of, so let's start with the topmost one, which is the one where the rider sort of interacts with your machine. So there, the information has to be crisp, clear, and reliable. So that has a certain set of algorithms. And there, the complexity is more about refining how easy you make the ability to read it. Then you can go, one level below, where you're actually talking about transferring the data, between different computers that are on the system. So let's say you have the vehicle control unit or the engine control unit, whatever you want to call it, and the dashboard. You need to ensure that the data is communicated without loss and without corruption. And this adds its own challenges. This becomes even more complex if you are now introducing things like wireless and Bluetooth and remote connectivity and OTA and things like that. So this is still at a very high level. But at an underlying level, when you start looking at the electronics level or the embedded firmware level, then you have a whole bunch of other challenges as to how quickly you're processing the data, what kind of data you're getting from the sensors, how valid the data is. So you actually have to not only get the data, you have to ensure it's valid, then you have to format it in a processable form. And you need checks and balances at each level, right? And of course, this is very basic engineering level description of what goes in terms of data processing. From a user perspective, very, very intuitive behavioral checks and balances become very, very much required. So for example, just for example, let's say you're going at 50, 70, 100 kmph. And let's assume that you have a mode switch functionality in your vehicle, right? You don't want the mode switch to happen just because the rider push some button by mistake or in an unsafe situation. So what happens if someone switches to a eco mode when you're in the middle of a very high speed overtake? I don't know, I'd say 80, 90 kmph, whereas your eco mode is designed for say 40 kmph. And what happens if a switch input comes when you're in the middle of something like that? So things like that will have to sort of be taken care of when we are talking about checks and balances. So it's really a lot of involved software work that goes into very detailed decision making, a lot of decision trees, and how each decision will impact different layers. So there's a very, very involved decision, and you need the right amount of checks and balances at each stage. Overdoing it, I think we had a scenario very recently where we were trying to address one particular fine-tuning aspect on one of our test vehicles, and we thought, okay, we are addressing point A, and we implemented this algorithm and we started testing it. While point A was actually addressed, what we realized is that point B, C, and D led to a completely unrideable vehicle. So that kind of a tie and balance is pretty important. You're on mute.
Yeah, we have one more question from Vivek Pavani. He says that you had mentioned you have a small team that performs diverse functions. What kind of product development experience would I have working in your company? And also, what type of skill sets are you looking for?
Okay, good question. Pretty much, so pretty much who joins in our team, we kind of grow them as engineers. At least so far, we have grown them as engineers. A lot of my core team leads and the guys who are right now making decisions joined us as interns a few years ago and have grown up from there. So in terms of product development cycles, you actually get to see everything, right? The earliest prototypes we've done things like doing 3D printed panels in-house and then reinforcing them with composites, stuff like that. So you do see, irrespective of which area of engineering you're from, be it computer science or electronics or mechanical engineering or operations, you do see every stage of product development in our company. But as I said, we are a very small team, and part of that comes from our selection criteria and our hiring criteria. So you absolutely have to be one, extremely passionate about what you are doing and why you're doing it and how you're learning it. Two, your commitment has to be towards your team. So no matter what problem throws at you, and I can assure you that no matter how well you plan things, there are things that will go haywire in ways that you don't anticipate it. How you work together with the team to sort that problem is point number two. Point number three, you have to always keep the product and the product's customer above everything else. And you need to be willing to do anything, like learn whatever it takes, implement whatever it takes, however quickly you have, whatever resources you have, and make sure that the product gets bettered. And that's the only way to do it. So these are the absolute three core tenets that we have to say that we have to look for. There's no good. Yeah, and the constant learning bit. The fourth aspect is constant learning, technical, non-technical, whatever it takes for you to level up, to deliver something that's asked of you, that has to be there. It doesn't matter where you learn it from. You could learn it from YouTube. You could learn it from an open source code, course, or you could learn it by contributing to some software on your own, or you could talk to the most senior engineers in the automotive industry and find out. But if that product requires that level of attention and detail from you, you need to be willing to put in that effort. That there's no bypassing that, there's no shortcut.
Okay, so Prajwal, Ranjita, thank you so much for joining us for this webinar. Thanks also to the audience.
Thank you.
Thank you, everyone.